My name is Görkem Ercan. I work for Red Hat mobile team. Some of the work that I do is around tooling for the Red Hat mobile. And also I work with the Cordova framework. I'm a committer on Apache, on Eclipse, and various other places. And today I'm going to talk about all things considered about Node.js, IoT, and OpenShift. The following talk is mainly about my personal experience, what I have been doing with in regards to IoT. So there is no guarantee that this will end up in any Red Hat product, if you're interested in that. But given enough eyeballs, it may happen. So here is my disclaimer about all this. So one thing, if you look at my background, you will see that this guy actually worked a lot with Java. Why doesn't he do Java for IoT, right? The reason for that is I did Java. And it's not because Java is bad. I think it's good. But I did Java on embedded. And the phone that you see there was the first phone that shipped my stuff. I worked for Nokia. I did Java on embedded. And I did OSGI on embedded when no one else was trying to do that. And at the end of 6 years, the Java licensing, it just doesn't work for mobile. And it doesn't work for, I'm doubtful that it will work for IoT. So what I did was, okay, I'm not a legal person. I'm not very familiar with the subject, but every time we tried to do something, there was always a licensing question in place with Java. And I don't want to think about that. I want to do my stuff, right? And Node.js doesn't seem to have that problem, so I continued to work with Node.js instead of Java. So the next thing that I looked at was, okay, I have all these sensors that I can play with. I have Arduinos. I can plug in new sensors. I can get data from different sources, and I can put them to different sources, and then I can actually make them get them together in a more meaningful way. For example, okay, if it's daytime and if the temperature is that, okay, that's acceptable for my son's room, right? So I could do all that, but one thing that I have realized when playing with different devices and sensors was that I need a gateway. Because when I talk with different parts, I need to sort of understand what they are saying and aggregate those data a bit and massage them, if you will, so that it actually gives me the opportunity to innovate on them or make them change. So I need a programmable gateway because I think the new business opportunities that will happen because of the hardware and software is going to happen due to gateway. And of course, there is the other problems. The other problems is you have a lot of protocols. If you have been in the talk before this one, you could see the parade of protocols, for instance. There are a lot of that. There is a lot of hardware differences. And of course, there are cloud services which do their own thing. And of course, there is the performance optimization where you can have one sensor going crazy and the other one is just don't want to talk, and so on and so forth. So for all those reasons, I thought that, okay, I need a gateway. And this is basically, in this talk, this is the key slide here. This is basically the architecture that I'm going after. So the architecture is, I have a gateway which can talk with my sensors and actuators and it can talk with them in different protocols. It can do Bluetooth, it can do coax, it can do TCP/IP, whatever you can do. So for that reason, I need something that I can program quite easily. And then it's connected to the internet, naturally. And on the internet, I have two things that I want to be able to do. Do device management and talk with services. So today, this is the architecture that I will be sort of targeting. So, and while I'm doing my talk, I like to do a lot of demos. And part of the demos is a sensor, which is beautifully architected here. So what I have here is a CDNO with a BLE sheet, so it's going to be on Bluetooth. And I have a base shield here because I don't want to solder stuff in. So the groove connectors allow me to pull in and out different sensors without actually doing any soldering. And I have a temperature sensor here, so it's very basic. And I have written a bit of code for the sensor. This is the main thing that it does. What it does is it reads the data from the temperature. So whenever someone connects to the Bluetooth adapter, it reads the data from the temperature sensor and publishes it to whoever is connected. So there's no security, nothing. It's a thermometer, if you will. And it does that in every 2 seconds. So, and all of the code related to everything in this demo is on GitHub already. So I'll show you the URL, so you can have a look at it. One thing to note is, so Bluetooth peripherals is a bit hard to work with because they are, on Arduino, you are working very close to the hardware. One thing that I found helps is a library called Arduino BLE peripheral. And it kind of helps you to write your code on a more generic way than very specific to the chipset that BLE, your Bluetooth adapter, comes with. Well, it's not too bad, actually. There are 2 chipset producers right now on Earth. So you need to just do 2 versions of your code. But this actually helped me a lot with that. So since we will be working with Bluetooth, a bit of, if you're not, are you familiar with Bluetooth at all, especially with BLE? OK. But I'll just do a quick intro so that you can see what I mean. You can read the code easier. So there is something called peripheral in BLE, and it's essentially your sensor. So it's the device that you read the data from. And there is something called central, and that's what connects to your peripheral and reads the data. And there is so Bluetooth itself is made up of several, I don't know how many now, but several profiles. And there is one called GATT, and which is basically the one for BLE. And it actually defines how you transfer data once you connect it to a Bluetooth device. And the way this is defined is it actually defines a service on your Bluetooth connector. And there are, inside those services, there are characteristics. And inside the characteristic, there is a value and descriptors. In my examples, you won't see any descriptors. But if you look at the code here, you can see that I have a service, a characteristic, which basically just puts the temperature in Celsius. before we go into that. So with that in mind, what I have done is I have started developing the first version of my gateway. So this is my first version of the gateway. So my first thing to do was, OK, let me just do a Bluetooth peripheral object on JavaScript, and then discover the sensors, and then read the data from them. And if we look at the peripheral object here, what it does is it uses a library from Node called Noble, and registers some listeners, discovers the services, and does all that, and then calls in another object called BLE sensor. And that one actually reads the data. So the BLE peripheral discovers the services and the characteristics, and BLE sensor just reads the data. Does it work? Yeah, it does. So let's run that. So now it's trying to discover the device. Let's put some power on that. And it discovered it, and you can see the temperature coming in every few seconds. And actually, if I just restart this, you can see the temperature. And it worked. But this wasn't what I really wanted, because I actually had to implement like a peripheral sensor, and then I realized that I'm missing tons of functionality that needs to be there. And it wasn't really highly programmable either. It was like, oh, I had to stitch this to that, and I didn't really like it. So I started looking at what my alternates are. Because, OK, this is easy, but it's not as easy as I wanted. So the next thing that I looked at was Node-RED. How many of you are familiar with Node-RED? There's one. So Node-RED is a Node.js application. And it provides an HTML editor where you can drag and drop your logic for IoT. So what you can do is you can just say, OK, I want to read data from Bluetooth and then pass that on to a MQTT output. Or you can say that, oh, I want to read data from one of the GPIO sources, and then read that and fetch that into Twitter. So the next thing that I did was, OK, so this is the new version of the gateway. Let me just, the next thing that I did was, OK, I have rewritten my gateway so that I have embedded the Node-RED into my gateway so that I can do the same thing much easier. So here is the result. So let me start my current gateway and go back to my browser. So this is my Node-RED editor. It's embedded into my gateway. So you will see in a minute why this is important. And let's try to implement the Bluetooth logic that I have just had with my earlier implementation. So I'll start with scanning. And I don't want to scan for all the service UIDs. I know that the service UID that I'm interested in is this one. Then read the characteristics of that here. I don't need to restrict the UID anymore because, well, there's only one. But if you want, you can do that. And just to show that I'm reading the data, I will just put a debug node here, which basically what it does is it outputs the message that travels between nodes to a debug tab over here. Or you can just put it to the console and debug tab. And hit deploy. So this will, as you can see, there is the little green that appeared in there. It says it's scanning right now. So it's trying to find my device, and it can't because I unplugged it. But if everything is working, it will find it, and we'll start putting the data. It will put it out once because, and you can see the data here, it's this one. It doesn't look meaningful because it's a Node.js buffer right now, so I need to do some sort of conversion to float data, but it's there. So it started putting that. But the example that you have seen was repeatedly reading the data, right? So I need to do that. I need to read the data repeatedly. So for that, I will do a delay here, get the output from here, and put here. So what this will do is, once you read the data, it will trigger a node that will do a 5-second delay, and it will send another message to my scanner. And what scanner will do is it will just report that, oh, OK, I have a device. Just read the data once more. So let's deploy this. Unfortunately, sometimes when I do a redeploy, it doesn't start immediately. So to keep the things flowing faster, I'll just restart my gateway. So what it is doing right now is it's reading the data and then waiting for 5 seconds and reading the data again. So this is actually what I wanted, because now it's highly programmable. Now I can just easily do this. And you know, I wasn't kidding when I said I can just send my temperature to Twitter. I can actually do that. I won't do that though, but. So I have these social nodes here that comes in with Node-RED that actually allows you to send data to Twitter. And you can do that repeatedly. I don't think that will gain you any followers, but yeah. At one point, since we are doing open source, we are using IRC a lot. At one point, I had an IRC node that actually started my blinking when someone mentioned my name. So that was fun. But then someone discovered that. OK, so once I did that, I started having a programmable gateway, right? But remember my original goal, which is here. I wanted device management. I wanted to do that because I wanted to go to my gateway and be able to say that, oh, OK, now you need to update yourself, or be able to say, oh, are you working? Really? Are you there? So to do that, I looked into the state of the art. And apparently, there is a protocol called lightweight M2M. It's from Object Management Association. And if you are familiar with that, they actually have a prior protocol called DM, Device Management Protocol. This lightweight M2M is very similar to that. How many of you have received an SMS message on your phone which magically configured your VPN or your internet access or something like that. If you have, that's DM, that's device management. So everyone in every phone operating system actually has it. Some of them have a very crappy implementation of it, but everyone has it. So the good thing about lightweight M2M is it's an efficient interface, and it works on CoAP, which is very lightweight, UDP, or SMS. The example that I'm going to do is going to use CoAP. And it has an extensible object resource model. And this is very important because with mobile devices, when you had OMA-DM, the capabilities of your device were pretty much defined. But with IoT, you will have many different sensors and many different actuators. There will be actuators or sensors that are very specific to one work. And they may be unique in the world for that purpose. So they are extensible, and there is a registry of object and resources, which basically tells you what object does represent what. For example, if we're talking about object ID 3, what it means is it's the device information. So if you look at this little XML here, you can see the fields on that device object. So if you have a model number, a serial number, and then you have some executables like restarting. You can see the power levels and so on and so forth. So and this is important because you want to be able to manage your devices, right? And the way to do that is to have a server that will be able to send and read data from your devices or send execute orders to your devices. So for that, there is a project on Eclipse.org called Electron. I think I'm pronouncing it wrongly, but what it does is it actually implements this server. And I'm actually running it right now. So let me just unplug this. So it's a Java server. And when it runs, you can just, it doesn't look very interesting, does it? So I have unplugged my device. I have, just a moment. Let me just see if I restarted my, okay. So what it does is, this is coming from cache. I'm sorry about this. Yeah. Now it will realize that there is nothing there. Yep. Okay, so as you can see, there are no connected clients right now. So the next thing that I did was, there is this wonderful server, and on the node side, what I need to do is I need to implement these objects and resources so that my node gateway can tell to the server that I'm here, and these are the services and data that I provide. So I went back to my node, and actually, because no one else implemented it before I did, I had to write some code. So I actually implemented a lightweight M2M manager, which basically just discovers the objects that it can present and discover and registers with the server. And then implemented a few of the objects. For example, I implemented the OMA device object, which we will see in a moment. So if we look at the implementation of the device object here, you can see that, oh, these are the attributes, and these are the data that I return for those attributes. And some of those are, as you can see, are actual functions. And you can see that this is the object URI that it registers to itself. So the 3 here is the object ID that you have seen on the OMA object registry, and 0 is the instance number, and pretty much on a device, 0 is default for this particular object. So let's go back to Electron and start running our gateway so that we can see that it actually registered itself as a node client to the server. And when we go back to here and try to read the data, you can see that it actually reads the data that you have. And for example, let's read the current time so that it actually executes a bit of code on the server. So what this enables you to do, because there are many things that you can do from here. You can say that, oh, what's the battery level? Or you can say, do a reboot. And I haven't implemented that yet, but I'm working on it. There's an object called software, and with that you can actually tell your gateway, or you will be able to tell your gateway to update parts of the gateway. And what software parts that it actually runs at that point. So this will give you a complete way to implement your, manage your gateway. But as you can see, one thing that is missing here is what's happening with the programmability thing, right? So let's go back to our node. So on the node side, I realized that, okay, getting the basic objects in place is important, but still you need to do some sort of programming, right? Because if someone does an M2M thingy and M2M call and you want to be able to make some changes, it needs to be easy. So I tried to tackle that by implementing, extending the Node-RED with a new implementation and saying that, okay, whenever I get a data, I will just update the Electron server and say that, hey, I have a sensor here. That's a new sensor with this sort of data. So let's do that. But before we do that, I want to do a quick thing. Remember that my data is still a Node.js buffer. Let's convert that first. And for that, I'm going to just write a quick converter function here. And get the data here. Let's get rid of this debugger. And put that and hook that into my sensor. And on that function, I'm just going to write a bit of JavaScript code that takes the data and converts it into Celsius, or float actually. And because I don't want you to type all this, I'll copy it and paste it here. Hopefully it will work. Let's deploy our flow. And okay, this is not hooked yet. Let's get our server running, gateway running, and let's hook our Bluetooth device. So if we go back to here and look at our node client, you can see that now I have a generic sensor here. what is happening here is when the Bluetooth data arrives and this node executes here, when it reads the data on node red, what it does is it sends the data to conversion. Let's name this convert data. And then what it does is it actually tells the gateway to register a new MTM object to the Electron server. And Electron, because it knows that, oh, this is the URI that is for a generic sensor, it can tell you that, oh, okay, this is, and you can actually read the data from here. So if you want to sensor value, if you read it, it's 24 something, and you can actually read the minimum and maximums as well that has been measured. And let's get this a bit. So we should read a higher. Yep, it gets higher. So in every 5 seconds, the data that is published to your MTM server changes, right? Because that's how the logic is right now on the Node-RED. But you can change that logic as well. It's basically just how you hook the things. You can change the way that you're hooking to your sensor, to your lightweight M2M server. Perhaps you don't do the delay. Perhaps you write a bit of logic and say that, oh, okay, if it's a significant change, then publish it to the MTM server or not. You can do that sort of changes. And as I mentioned, this is all working on top of CoAP. So let's go back to our original slide. So next thing is okay, I can do device management somehow. There's still some way that I need to do. But next thing I wanted to do was, how about services? Can I hook into services that are running on an MBAS or on an OpenShift instance? So, for example, can I work with Apache ActiveMQ or Red Hat JBoss Fuse or FeedInry MBAS? Can I do that? And the first thing that I discovered was, yes, I can, because I have a Node-RED which provides me with tools to invoke an HTTP service. That's very easy to do. But that kind of kills the whole point, because your gateway is supposed to be able to work on more constrained environments. And if you have been to the prior session, you would know that HTTP is not that. So I wanted to do either CoAP or MQTT, and MQTT seemed like the popular one. It has more Google hits. So I looked at MQTT. Are you familiar with MQTT? Have you heard of it? Yeah, so it's a publish, subscribe, messaging, transport. It's very lightweight. It doesn't have too much overhead. It's very lightweight protocol. So I wanted to do MQTT. And I wanted to do that on OpenShift and with Node.js. And if you're familiar with OpenShift, you would know that that's a challenge. So, okay, so in OpenShift, you have a Node.js instance that you can start. It's a very standard instance. The problem with it is it only provides you with support for HTTP and WebSockets. Why is this a problem? Because MQTT is neither of those. But one thing that you can do is you can actually run MQTT on top of WebSockets. So what I did was I went out there and started looking for a solution for running Mqtt Broker on OpenShift with Node.js on WebSockets. And that was possible, to my surprise. So there is a project called Mqtt, and it's a Node.js project. It actually uses another library called mqtt.js to implement an Mqtt Broker. An Mqtt Broker is basically a server that understands MQTT and does something when it receives the data. And the good thing about Mqtt is you can actually configure it to use different backends. So you can just say that, OK, do a store and forward, and it will store your data on a MongoDB and forward it, and so on and so forth. So my implementation here is basically a real-time broker. So what it does is whenever it receives a message, it will just publish it once again. So it doesn't do store and forward or other fancy stuff. But you can do that. I have tried it. The only trick part here is the Mqtt configuration is a bit tricky. And it took me like a couple of days to realize that if the port and host is not defined for both HTTP endpoint and the general endpoint, then it tries to open the port twice, and OpenShift doesn't like that. But other than that, it actually works wonderfully with OpenShift. So now I have my instance running this server code here, and this is all the server code I have on OpenShift. And so this is my instance. So the next thing is, of course, go back to my Node-RED and pull in an MQTT output. There is one. Oh, this is an input. So this is my output. And you can see that it says MQTT Advanced. And the reason for that is this is my hacked up version of the original MQTT node. Why it is hacked up? Because the original one does not permit me to select the protocol that I want to connect to the broker with. So I wanted to connect over WebSockets to my broker. But the MQTT node that comes with Node-RED does not allow that, although the underlying library does. So what I did was I did a few changes to the implementation. The original one is still here. And if you want to see that, it's still here. So the difference is now when I define a broker, I can actually select the protocol for it. So that's the only difference that I made. And a few other things as well. The other change I made was I wanted to be able to define if I wanted compatibility with MQTT version 3.11. And also I wanted to be able to say that if there is security involved. Now it's not working, but if there's security involved, I wanted to be able to say that if the certificate is not invalid, just accept it. Because sometimes you're using a test server that has a fake SSL certificate. So in those cases, you want to still be able to continue. So those are the changes that I made. I'm planning to provide these back into Node-RED project, which is an open source project started by IBM. So this is my MQTT Advanced. And I have a topic that I'm running called IoT sensor. And what it does is it will just take my whole message payload and publish it as an MQTT message to the broker that is running on OpenShift. So let's deploy this. Let's see if this started to do this lately. Sometimes it just needs a kick. Otherwise, it just waits for a while, depending on the day. So as you can see, now my topic, IoT sensor, is connected and probably publishing data to my Node.js server. So how do we see that data, right? Let's go and implement another MQTT client, this time with on HTML. So what I will do is I will use the client from Paho project, and it actually will go into my Red Hat OpenShift broker and read the data, whatever comes from there, and put that data into a charting library. And where is that? If it works, of course. And at the moment, it's not. So where is my data going now? Yeah. Oh, is it because I'm not plugged in? Let's restart the whole thing once more and see if my chart is back. Yeah. Now it started to read the data, connected to the broker. Yeah, it started to publish the data to the MQTT broker running on OpenShift, and now my client that is embedded into this HTML page is listening for all the topics that are coming into my broker and just charting it here. So you can see, let's make it a bit go higher. It should start going up in a moment. It's 24.6 degrees Celsius. So yeah, there is a delay, of course. It reads the data every 5 seconds, and then it goes and all the way to OpenShift instance, and then publishes back into my client here. So yeah, there is a lot of delay unnecessarily. So this is where it is, my gateway project right now. And all the code for that is available on my GitHub account. I guess you can read it. So what my plan is to continue on this path, because so far what I'm doing seems to be working for me, at least. And my home projects, I can pretty much control what's happening in my son's room, which is hard to say. So that's where it is right now. So the code is there. I will continue to update it as much as I can. As I said, this is not my main responsibility in Red Hat, but I do this in the afternoons and so on and so forth. And if you're interested in IoT, there are many more talks about IoT during the week. Especially, I would suggest the middleware keynote. There is a lot of IoT demo there as well. And we have a hack night on Wednesday on IoT. And of course, there's a party. Let's not forget about that. We have a party. You will find the information on Hall D.